information, to bring more information into just all of what I'm talking about, is understanding everything at the finite micro level. And that is understanding like atoms and electrons and stability versus instability. And then, negentropy and entropy are, yes, mechanisms that involve chemical reactions to either lose a life force or gain life force. And if you gain too much life force, that could also cause a person to lose life force relative to where they're drawing that energy to gain life force. So it's like it's a balancing act. And so this is what I must understand with negentropy and entropy. It's not really like either or, it's how you balance them out. And so if you're losing energy, then you must gain the equal amount of energy that you're losing. That'll keep you in like, a homeostasis, an equilibrium. But if you're losing more energy than you're gaining, then that is the entropy, right? And if you're gaining more energy than you're losing, then that is also could be an entropy type of thing because you're causing an imbalance. Because you can have too much life in your body, which would be then like tumors and cancer and obesity and whatever else, and you're not losing the energy relative to what you're gaining. So you almost have to understand that the balance of negentropy and entropy is based upon how the body utilizes energy in the environment and what is influencing the body to go through an evolutionary or a de-evolutionary type of mechanism. Okay? And so I was looking up like differential equations yesterday, and I was looking up all these different things and classical orbital paramagnetism and non-equilibrium steady state. Well, when something is not equilibrium, non-equilibrium means it's unstable, right? And that is an unpaired electron. So unpaired electrons can cause instability, and that has to do with, but is instability bad? Not necessarily, because you could be evolving to another high level of existence. You could have a virus in the environment, and your cells in your body are now, be impacted by that. And so there might be, the way atoms attract each other, covalent bonds, all these different things. You might have an unpaired electron that is now causing more energy than it would have if it was like paired with something, right? So non-equilibrium thermodynamics is a branch of thermodynamics that deals with the physical systems that are not in thermodynamic equilibrium but can be described in terms of variables, non-equilibrium state variables, that represent an extrapolation of the variables used to specify the system in thermodynamic equilibrium. Non-equilibrium thermodynamics is concerned with transport processes and with the rate of chemical reactions. It relies on what may be thought of as more or less nearness to the thermodynamic equilibrium. Almost all systems found in nature are not in thermodynamic equilibrium, for they are changing or can be triggered to change over time and are continuously and discontinuously subject to flux of matter and energy to and from other systems and to chemical reactions. So even being around people who have different chemistry to you can trigger some kind of non-equilibrium type of mechanism. Okay? But you can still have inertia. You could still be in a non-equilibrium type of system, but still be in inertia of a death trajectory or life trajectory. So it's all relative to what you are applying inertia to. Okay, so some systems and processes are, however, in useful sense near enough to thermodynamic equilibrium to allow description with useful accuracy by currently known non-equilibrium thermodynamics. Nevertheless, many natural systems and processes will always remain far beyond the scope of non-equilibrium thermodynamics methods due to the existence of non-variational dynamics where concepts of free energy is lost. So, the thermodynamic study of non-equilibrium systems requires more general concepts that are dealt with by equilibrium thermodynamics. One fundamental difference between equilibrium thermodynamics and non-equilibrium thermodynamics lies in the behavior of inhomogeneous systems, which requires for their study of knowledge of rates of reaction, which are not considered in equilibrium thermodynamics or homogeneous systems. So, rates of reaction. See, even politics is its own chemistry. Do you realize how much energy you use when you actually, get involved with politics? That's creating a non-equilibrium thermodynamic. It's how much energy you are expending versus the energy that you're retaining, but you have to have that balance. And then I'm like, okay, how many what did I say? I was going through all this. This is like, I love Google. So, electrons. And I was like, how many electrons make an atom unstable, right? Okay, this is known as the octet rule, 8, right? which states that the exception of innermost shell, the atoms are more stable energetically when they have 8 electrons in their valence shell, the outermost electron shell. Okay? What makes an atom unstable? An atom is stable if the forces among the particles that make up the nucleus are balanced. An atom is unstable radioactive if these forces are imbalanced, if the nucleus has excess of internal energy. Instability of an atom's nucleus may result from an excess of either neutrons or protons. So the number of electrons, so how does the number of electrons affect an atom? The number of electrons in an atom's outermost valence shall govern the chemical properties. Elements react to form a closed shell corresponding to the electron configuration. This tendency is called the octet rule because atoms have 8 valence electrons. And then, are ions stable or unstable? An atom can be considered unstable in one of two ways: if it picks up or loses an electron. So you have 8 electrons. Okay, that's a stable atom. And if it picks up or loses an electron, it becomes electrically charged and highly reactive. Such electrically charged atoms are known as ions. Instability can occur in the nucleus when the number of protons and neutrons is unbalanced or are unbalanced. Because what is C14? Why is C14 unstable? I don't even know what C14 is, but it's just a question in here. Because carbon 14 has 6 protons. It is still carbon, but the 2 extra neutrons make the nucleus unstable. In order to reach more stable state, carbon 14 releases a negatively charged particle from its nucleus that turns one of the neutrons into a proton. Why is iron the most stable element? This stability is caused by the attractive nuclear force between nucleons. Iron 56 is the most stable nucleus. It is most efficient bound and has the lowest average mass per nucleon. It takes more energy per nucleon to take on the nuclei completely apart than it takes from other nucleuses. Nuclear properties. And then why do electrons stay in the atom? Oppositely charged particles attract each other, while like particles repel one another. Well, that makes sense. If my husband was like me, we'd kill each other. Electrons are kept in the orbit around the nucleus by the electromagnetic force. Because the nucleus is the center of the atom, is positively charged and attracts the negatively charged electrons. And that's like the orbital, paramagnetism, orbital, diamagnetism. And so that's what I was doing yesterday, was looking up all this stuff. But now, after studying that yesterday, and then I'm looking at negentropy and entropy and equilibrium, and that no matter what, when you're in entropy or negentropy, you're going to have a non-equilibrium state until you reach that equilibrium. And when somebody's adapting to their cancer, disease, and chronic illness by taking out organs, they'll reach a point of equilibrium where they don't feel anything for a minute until the body starts breaking down even more, and then they're taking more of their pills and their powdered supplements. And so you'll reach different levels of equilibrium on your way out the door or on your way in the door, because it has to do with how your environment is impacting your work cycles. Okay, so this is so interesting. So yeah, so now I understand that even with negentropy, it must be balanced correctly, because negentropy is a life force that you're retaining, but you retain too much life force, you have cancer and you have obesity. And if you're losing too much life force, then you're aging and you're degrading. And so, why is it that when you have too much life force, like cancer, why you're still aging and degrading? Because it's taking more energy that you're able to regenerate. It's usurping the energy and potentially shutting down vital organs. So it's all a balance. If you're going to grow something, you better have enough energy in your reserves to be able to handle that conversion, that energy conversion. Because even converting energy takes energy. Everything takes energy. You got to have enough in your little bank account to be able to regenerate. If not, then you're just, then you start cannibalizing yourself. That's the aging process, is basically self-cannibalization. And so negentropy is autonomy, but there's still a balance. You have to have a low-level entropy so you're able to release the excess and regenerate. That's a balance of negentropy and entropy. I had to really verbalize this. And then the whole thing with the electrons and atoms have to do with the state of the body during its entropy state or during its negentropy state. Okay? So yes, evolution takes energy, and so does de-evolution. All right. And you have to endure the symptoms, the work cycles. All right, bye.